Hello dear friends, in this video I will explain how to calculate wind loads on structures similar to my greenhouse. I will demonstrate these calculations using my own greenhouse. Click on the house icon, then part. Now we will create the ground on which our greenhouse will stand. Select the front plane, sketch, choose center rectangle, and draw it like this. Next, from the quick access ring, select automatic dimensioning. I set this side to 12 meters, specifying in millimeters, by 9 meters. Okay, alright, then now go to the extruded base and set it to 100 meters. There. Next, to make it look more realistic, I'll assign it some material. I'll go into iron and point out iron. Line close. There. The texture looks similar to soil. Now file, save as. I save it in the folder I need and name it soil. Measuring 12 meters by 9 meters in total size. Enter. Now we close this file. Click on the home icon and select assembly. We're creating an assembly. Now we insert our soil here and align the coordinate center of our part with the coordinate center of the assembly. These icons appear. When we click, two such icons from the coordinate centers appear, and the soil is placed at the center of the assembly and fixed automatically. Now go to Assembly, click Insert Components, and find our greenhouse. Here, select our greenhouse and click Open. There it has been inserted. Now let's add a mate. Select this face and this face. A relation has been added, a coincidence. Excellent. Now go to Advanced and select Width Mate here. Select this face and this face. Now this face and this one. Now our greenhouse has moved to the center of our surface. Now we carefully move it back just a little and go back to the standard mates. Select the distance mate, this face with this edge, and set it to 3 meters, 3000 millimeters. Okay. And now let's save our project. File, save as. And now let's find the folder where we will save our greenhouse ventilation project. That's it for this step. Now, let's move on to the next part of our process. We are going to write the following terms carefully and clearly. Assembly, greenhouse assembly, and finally, ventilation. Make sure to write each word neatly and in the correct order, as this will help keep everything organized. Start by writing assembly on your page, then add greenhouse assembly just below it, and finish by writing ventilation at the end. Once you have written all 3 terms, double check your work to ensure everything is spelled correctly and looks just like the example. Great job, just like that. Now we save. Go to Flow Simulation Wizard. Here, leave the default configurations and everything else as default. Move on. Make sure that the pressure is set to pascals and the velocity is in meters per second. Then move on. Here, select External. The simulation type is external. And here, check the boxes for excluded surface without conditions to, completely exclude without flow conditions, and exclude internal space. Check that box as well. Next, select the environment, gases and air. Next here, we set the roughness to default values. Then, along the x-axis, we set the velocity to 40 meters per second. That's correct. The blue arrow indicates the wind direction. If I set minus 40 meters per second here, the direction changes. Remove the minus sign, it goes the other way. And now click finish to complete. Now it creates a huge computational domain for us. Now we'll adjust it. Ctrl 8. You're perpendicular to the screen. And now here we set minus 6. On the other side as well. 6. But this time without the minus sign. Set the height so that our ground is below the calculation area. Otherwise, SolidWorks will consider the ground as the only solid body and will have a tornado raging inside the greenhouse, which we don't want. That's why we move the ground out of the calculation area. Set it to 0.1 because that's 100 millimeters the height of our ground. Now let's adjust the sides. Set it to 4.5. And on the other side as well. Only this time, minus 4.5. Just like that. The height is 4 meters. 4 meters. There. That's it. Now we can start the calculation. Go to calculation, and here I use all the cores and click run. That's it, it's preparing the model. Here there's a button called section view. With it, we can cut our greenhouse in half. If I select, for example, the plane from above, it will cut our greenhouse. Let's imagine that this is our greenhouse. And the plane passes through the middle. It will cut our greenhouse in the middle, and we'll be able to see what's happening from the side in the lateral section. Right here, you can see exactly how the air will enter our greenhouse. Like this, splash. I select the plane from above and click OK. Now we can see this side view. This is what's happening with our greenhouse right now. Close this, leave that. There, the calculation is complete. We close it. Let's go to the results. We add the flow trajectories. I'll specify the plane on the right. I'll set 60 arrows. This plane is the direction along which our flows will move. And we click OK. And there we go, our wind flows have appeared. They will be here. Let's even turn on the animation. Here, the flows are moving. They pass over the greenhouse roof and start swirling here. Now we need to transfer these calculations to simulation. Let's hide our flow trajectories. Next, we go to Tools, Flow Simulation, Tools, and here we do it. It says that all the results have been exported successfully. Click OK. Now go to Simulation, New Stage, Static Analysis. Okay. It's calculating the joints in my greenhouse, all the welded structure attachment points. Done. Now here, in Flow Simulation, let's hide our calculation area. Now here, let's exclude the ground from the analysis by right-clicking, and now let's go to the greenhouse and check if all the materials have been assigned correctly. Let's select one of the beams. Aha! It says galvanized steel. Close. Here, it's assigned correctly. Next, let's check our polycarbonate. Aha! Everything is correct. Close. Now let's add fixed geometry. Fix geometry as points and select our points. There, we've simply selected all the points and click OK. And add the flow effects force. Here check include fluid pressure effects from SolidWorks flow simulation. And the points. Here is our calculation, enter. And uncheck, dissolve outdated studies, exclude shear stress. And click OK. Now let's also add gravity. The planes are in the front direction. And OK. That's it. Now we press. Let's start the calculation. Wait until it generates the mesh.
Hooray!
Here our calculation has been completed. Now we will make some changes. We'll introduce displacement, move the cursor up, and add deformation. Next, we turn on True Scale, go to Chart Options, change the table to floating, and enable Show Max Annotation, which displays the maximum deformation parameter. And then we click OK. Now we can see the deformation caused by the wind. This is the wind-induced deformation we obtain. And here is a slight deformation from gravity. SolidWorks intentionally displayed it as weaker, since the wind deformation is much stronger. Next, you save the file. Let's save it. Save. That's it. Now we remove our static study by right-clicking and selecting delete. Now let's make a clone of the calculation. Here, go to Mate, delete the width mate, and delete the distance mate. Actually, go to Mate, add a mate, Advanced, and select width. Take this surface, right click to select yes, and this one. Now carefully specify this face and this face. It calculates using simulation. Okay, now this face, go to standard. Now here, instead of distance, set and select the second surface, this one. Set it to 3 meters. Enter, enter. Okay. Okay. Now go ahead and go to simulation. Check to make sure our calculation area is the same as in the previous calculation. If it is the same, then click run and start. Here our model calculates and checks. And now the calculation has started. Here the air pressure is being shown. Alright. I click and wait until the calculation is finished. Now close it and check the flow trajectories. Here. There are vortices here and here. We close them again. Go to Tools, Flow Simulation, Tools, and Export. Allow the simulation tool. It says everything is completed successfully. Now go to Simulation, New Stage Static. Okay. Wait until it calculates the points. Now exclude the ground from the analysis. open the calculation area. Now, add the fixed geometry. Added. OK. Now, gravity. The plane in front. And we add flow effects. Include pressure effects from flow simulation. Check the box. Now exit folder 1 and go to folder 2. Here, select calculation number 2 and open it. Now check the box to run the deprecated study, exclude shear stress and click OK. Now click Run the study. Wait for the mesh to be calculated and the computation to start. There, our calculation is complete. Go to Displacement. This is the deformation through scale floating table. Show the maximum pressure parameter and click OK. Now we can see that the wind pressure is more clearly visible here. Because it's coming from this side, the wind came from this direction and hit the side of our greenhouse. And it created this kind of spot. The maximum then turned out to be 0.111 millimeters. This was Alex Evsifi with you. We have calculated the wind load on my greenhouse, and now you can perform this calculation for different structures as well. Goodbye everyone. Don't forget to subscribe to our channel and like this video.